about it. Okay, so I'm going to record this. This is the new material. Again, I changed the homework, so tonight you don't have homework, but you're going to try to do some notes today, and then tomorrow in class you'll work on this. If you somebody could go to tutors, that kind of thing. If you have a tutor today, you could take the notes home, or you could watch the YouTube. So that would be. If you already know how to do some of this, while I'm explaining it to the kids that don't know how to do it, you can work on your own and try to do these problems. Okay, but there's new vocabulary again here. So this is section 3.3, and the goal of section 3.3 is to find something called the greatest common factor. And you'll notice that greatest common factor, I highlighted those letters because a lot of times you'll hear people say, find the GCF, the greatest common factor. It's quicker. So that's why those letters are in red. And so the greatest common factors would be like for the numbers 16 and 20, you're trying to find the biggest number that's in both of 16 and 20. Okay, and probably some of you can do that in your head, but as the number get bigger, you want to have a system. So we're going to go through a system. So you guys, your goal today is to do this problem, be able to use 3 techniques. And we're going to go through all 3 techniques. Okay, so the first technique is making a list of all the factors. So we're going to start with technique number 1. All right, so what I'm going to do is take 20 and take 16 separately and find all the factors. So for 16, I know that 1 times 16 is 16. It's even, so 2 times what, Sam, is 16? 2 times 8. Does 3 go into it, Sam? No. How about 4? 4 doesn't go into 16. Do you agree, Jason? You disagree? How many times does 4 go into 16? 4 times 4. Right, Sam? Does that make sense? So there's the repetition. Remember we talked about repetition? Once you have repetition, then you know you have all the factors. So the factors of 16 would be those. Okay? So now I'm going to find the factors of 20. So Nathan, let's do that. 1 times 20.
20.
What else?
10 times 10.
Okay, so 2 times 10. Does 3 go into it?
No.
4?
Yes.
4 times 5. See how close 4 and 5 are? So as those numbers get closer together, you're getting to the end. And so what's the next factor that goes into 20, Nathan? It'd be 5 times 4, right? So that's the repetition. Once you get to the repetition, you know you have all the factors. So here are the factors of 20. Okay? So the first part of the list method is to find the factors of both numbers. Does that make sense? Then you line them up. And, you know, maybe write them out. So the factors of 16, if you write them in order, 1, 2, 4, and 16. And then the factors of 20 are 1. Oh, I left 8 out. Thank you. It's on the list over here. I just lost my focus. 4, 8, and 16. Better? So the factors of 20, 1, 2, 4, 5. Looking at the list, the next one's 10, 20. Now, you look at the list, and you compare them, and you find the factors that are common to both. So 1's in both, 2's in both, and 4's in both. But the biggest one that's in both is 4, so that's the greatest common factor. Yeah, Tanner. Yeah, and I'm going to do it a different way too. You are going to try all 3 ways in the homework, because the homework asks you to do 3 different ways, which is a good habit to know the different strategies, especially if you, for the different size numbers. Sometimes this making a list is the easiest way, but if the numbers are big, it's not a great way. And the division ladder could be a great way. We'll do that next. And for some people, the factor trees is a nice way. And there's lots of different people in the room, so usually different methods help different learners. So we're going to go through more than one way. But the final answer, when you write this out, after you do all that work, you would then write your answer and say the GCF, or the greatest common factor, of 16 and 20 is, what is it? 4. And that's your answer. So you heard Tanner say he does it a different way. You should get the same answer. Could you do it a different way and get the same answer?
Yeah.
What way did you use?
I used the factor trees.
Okay. So let's use the factor trees next then. And we'll let you explain that. So I'm going to switch order. Yeah, that's my favorite way. But let's see your way first. So first of all, just so you guys know, we're still looking at finding, I'm going to just rewrite what we're trying to do. We're still trying to find the GCF of 16 and 20. Since I scrolled down, you might not know what the question is. So what'd you do first?
I put down 16 and 20.
So put down a 16 and a 20.
And then for the 16, I do 4 times 4 is 16.
So he's doing a factor tree for each one. So for 16, he said 4 times 4 is 16. So then he continues the branches. So the good thing about this method is it makes you practice yesterday's work. And 2 times 2 is 4. So you have some primes here. Right, and how about here?
And then I did 5 times 4 is 4, yeah, that's 2 times 2. And I did 5 times 4 is 20. And 20.
So these are also 2's. So first he's just getting his prime factors. And then he does a similar thing with the 20. So he said 5 times 4, you said?
Yeah, 5 times 4 is 20.
Yeah. So 5's prime, right?
Yep. And then
2 times 2 is 4. Circle the 2's. Those are primes.
so now you have all your common factors. So each, like if there's a 2, then you go over to the other side and then you use that 2 cross that 2 off.
Okay. Okay. So I'm going to write that out, what he just said. For people that have never seen that, that's a lot of information. So for 20, what Tanner is saying is you've got all these factors, 2 times 2 times 2, I mean for 16. For 16, let me try that again. That's a big eraser. Let's do a smaller eraser. Okay. I'm going to make a little more space. So for 16, you have the factors 2 times 2 times 2 times 2. And those came from here. Do you see that? Okay, and then he said for the 20, you also have some factors, and some of them are the same. So what I usually have kids do is write them out so they're the same, they line up. Like you have 2 2's, so 2 times 2, but that 5 doesn't really match any of the 16, so put it over here. And then look at the common ones. That's common, and that's common. This isn't common, this one, because there's not another 2. So you only circle the ones that are common. And then what do you do with that?
And then 2 times 2 is 4.
Yeah, then from there, you take that number, 2, and the number 2 from here, and you multiply them, and you get 4. And remember from the last method, we found out that the GCF of 16 and 20 is 4. So it works with the factor tree. For some people, that's the best method. It really looks different, especially if you've already learned that method and you're really good at it and you like factor trees, that's a great method. For some people, the list might work better. And for a lot of people, the division ladder is going to be really nice. So we're going to look at all 3 methods. Questions, Sophia?
I just don't really see the steps.
Yeah. Give me a chance to go through 3 methods, and then I'll do them again with another pair. Okay?
Because I just don't.
Yeah, that's a lot of information. So Tanner clearly has done this before and remembers it, so it doesn't seem like a lot to him because he did it last year. But most people would need to practice one more time, or at least once. So I'll do another example. Jack.
What if, like, all 3 of those methods, like, none of them really click for you?
They will. You practice all 3, and then one of them will become better than the others. It usually does. And if those 2 don't click, I think you'll like this division ladder. So for the division ladder, we're going to do the same thing, especially if you guys have been using the factor tree. We're still going to do the same question. Oh, look at what that recognized. Not quite my writing. My writing wasn't perfect. So same question with the division ladder. Watch the division ladder. It's really neat. You take 16 and you take 20 and then just draw a line right down the middle and then draw like a box like that, or sort of like a table. It's kind of like a tea table. Yeah. And now you find common things to 16 and 20. So like 2 goes into both of them because they're even. Okay? So I'm going to start with 2. And because I know 2 goes into 16 and 2 goes into 20, I'm going to put a 2 right here. So Kayla, what's 16 divided by 2? 8. So I put my answer, the quotient, below. So Zoe, what's 20 divided by 2?
It's 10.
It's 10. So I put the answer below. And then I continue my division ladder. So I'm going to just draw another box like this. And then, Augie, is there anything common to 8 and 10? 2, right? So I put a 2 here. And then 8 divided by 2 is what? 4. And 10 divided by 2 is 5. Is there anything other than 1? We don't use 1s in the division ladder. Anything common to 4 and 5? No. Okay, so what you do is you take these numbers on the side and you multiply them to get your answer. And so we have the greatest common factor, or the GCF, of 16 from up here. It is easy. And 20 is 4. Isn't that easy?
Yeah, that was great for me.
Yeah, that one's for me too.
Yeah, great for me.
Here's the thing about the first method. If we look back at the first method, well, let me do 2 things. I'm going to go to another page. But if we look at the first method, the reason that this method's nice up here at the top, this method, is because it really gives you an understanding of what the problem's about. The first method makes you see that it's the biggest factor. The third method is really nice because it's so easy
It's quick.
and quick. And the middle method, I have to be honest with you, it's not my favorite method, but I have kids every year that they like that method the best. And it gets them to the answer, and they do it really well. And they're always practicing prime factors, so it's a great method for a lot of people. So just because one method is nice for one person, it doesn't mean that everybody would like that method. So in section 3.3 in the book, you practice all three. And when I give you a quiz, I'll probably have you do all three. I'll say, find the GCF using the division ladder here. And then another question I'll say, find the GCF using a factor tree. So I'll probably ask you to do it once, each method, and then I'll let you choose on the rest of the quiz. Nathan?
Are we also going to be doing the greatest common denominator?
It's not, there's, that doesn't really, that's not really, you might be thinking of something called the least common multiple.
Yeah.
And we are going to do greatest common denominators with fractions. Yeah, that's actually why we're doing this. So two different things. So yes, but not today. Okay. So I remember that, Sophia, you said that wasn't really clear, the method. So that's why on the second page, I have like extra examples. Okay. So we're going to do the same thing with 30 and 45. Yeah. And I'm going to make the page bigger. Okay? Or can you guys see that? It seems like if the page is bigger, it's better for you, right?
Yeah.
So let's go to the single. Okay. So making the list of factors, I'm going to have you help me, Sophia. What's 1 times 30? What's another thing that goes into 30?
5 times 6.
Okay. Try not to skip anything, but you're right, 5 times 6. Does 2 go into 30?
Yeah.
How many times?
2 goes into 30. Well, no.
It's cutting it in half.
2 goes into 30.
Who can help? Half of 30. Okay, Emily. 15. Okay, and then how about 3, Sophia? 10. And does 4 go into 30? No. And then you said 5 times 6. Again, you guys, I want you to notice 1 and 30 are pretty far apart, right? 2 and 15 are closer. 3 and 10 are closer. 5 and 6 even closer. That means you should almost be done. And the next, or all the way done. The next thing that we would see is 6 times 5. So there's the repetition. So that's our list of factors. So I'm going to write our list of factors for 30 off to the side. 1, 2, 3. What else? Oscar, what's the next factor? 1, 2, 3. The list is right there. 5. Keep going. 6. Anything else? You skipped one. What did you skip, Ethan?
15.
15 and 30, Oscar. Okay, so that's a lot of factors. Okay, so Ethan, can you do a list of factors for 45, 1 and 45? Is it even?
No.
So 2 doesn't go into it. How about 3?
Yes.
It does. Does anybody know how many times?
15.
Good. Good job, that's 15. Does 4 go into 45?
No.
No. How about 5?
Yes.
Yeah.
It goes into it. 5 times 8. Yeah. 9 times.
Not 9. How about 6? How come? Who said no? Jason, how come? It's not even. And for 6 to go into a number, 2 and 3 have to go into it. So that's right. Does 7 go into 45? No. 7 times 6 is 42, right? So how about 8? Does 8 go into 45?
No.
But 9 does. And then we have our repetition, right? Okay, so our factors are right here for 45. So when we write them out,
1, 3, 5.
we have, right, 1, 3, 5. What's the next one? 9,
15, and 45.
45, right? So now we look for the one that's the biggest one that's common to both. So 1's in both, 3's in both, 5's in both. How about 9? How about 15?
Yeah, 15.
Yep, and that's the biggest number that's common to both. So we say the GCF of 30 and 45 is what? 15. Okay? Raise your hand if that makes sense. Okay, Brain, you're going to help with the next one. Let's do division ladder. So do you remember what you do first?
Yeah, you write the two numbers and then you draw a line.
So what are the two numbers?
They're 30 and 40.
30 and 45, and you draw a line separating them, right?
Yeah.
So just separate them like a T-table. Okay, can you pick a number that's common to 30 and 45? 3? Sure. 3 goes into 30 how many times?
10.
Good. How about into 45?
15.
15. Okay. So then you keep the division ladder going. What's common to 10 and 15? 5. Okay, so 5 goes into 10 how many times?
5.
Okay, and 5 goes into 15 how many times?
3 times.
3 times. What's common to 2 and 3 other than 1? Nothing. So you take these and you multiply them, and you should get the same answer that we got before. Did we get 15? Yeah. Sean.
Did you forget that you only had one GCF? Like for just one factor, couldn't you just divide it by 2?
What do you mean? I'm not sure what you're saying.
If you had one factor that you were trying to find the GCF of, couldn't you just divide it by 2?
Oh, no. So the term GCF means you have to have at least 2 numbers because you're trying to find something common. One thing I want, does that make sense? One thing I wanted to tell you guys is you could do division ladders differently and get the same answer. Like, what if somebody said, well, I thought 5 went into both? Yeah, 5 goes into 30 how many times?
It wasn't 6.
6. And 5 goes into 45? 9. And now, what goes into 6 and 9? 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So here's your GCF. 5 times 3 is still 15. So you don't have to do the division ladder the exact same way. Does that make sense? I think we have time to do the factor trees, and then I'll save this, and then you have no homework, but you practice tomorrow in class. Okay? So I'm going to wait though. We want to do the factor trees for 30. What were the two numbers?
45.
And 45. Okay. Let's see. Sean, start one.
35.
Okay. Okay. Right, because it's prime. Good. Okay. So then off to the side, we're going to just write the list for 30. So it's 2 times 3 times 5. And now, somebody else, Bryce, do 45 for me. 15 times 3, okay. Circle the 3 because it's prime. Good. And those are your primes. Okay, so over here, we're going to write under that 45's prime factorization. Right, so look what I do. I only line things up that are common. So 3, I have a 3, but I have another 3, so I stick it over here because there's not another 3 here. So I've taken care of this 3 and this 3, but now the 5 I'm going to write right under the 5 because that's common. So this is that other method. You line up the common factors. It might not be the best method for everybody. I see some of you making faces. You line up the common, but you have to practice it, and then you'll get better at it. So Jack, what do I do with those two numbers in circles?
You put them in like quarters. You
So let's look at the other page. So I took the common numbers on the other page. What did I do with them? Right here. I brought them down, that's true, and then what? Multiply them, right? So even though this isn't your favorite method, because you said you like the ladder, you still want to practice it. So I'm going to bring down what number over here? 3, and I'm going to multiply it by what number? 5, good job, Jack. And then when I multiply those, I get 15. So it's the same answer as way up here. The greatest common factor of 30 and 45 is still 15. Okay? So they might take practice, but I think you guys are going to get it. You just have to think about it a little bit tomorrow and try to practice. So let's pack it up and get ourselves nicely organized, and I'll save this.